All right, folks, we got a minute and 55 seconds until we get started here. Hope you're all having a wonderful evening. Sadly, I am in here while my roommates watch. I can't remember what the name of the movie is, but they were watching some. I don't know. It's a romantic comedy. I'm not entirely sure. If we check the leaderboard, yesterday we started late because we were driving home from that lake house I was at, so our scores were not particularly good, but if we subtracted about an hour and a half off of that, that's about the time that it would have taken. If we look at our private leaderboards, surprisingly for work, Kevin Chung is only missing 3 stars headed into day 22, so just a little bit of optimization to be done. And we only have 4 days left, which is kind of sad, but this has been a fun little task for us. Honestly, I wouldn't mind having a job where I needed to do some stuff late at night like this. And if I look at the private leaderboard, obviously this other one is complete domination. There's only one star that I did not get first. Now, if we check over here, we have already done the relevant. We've already done the relevant updating of main so that it points at level 22, and level 22 itself. Also already has the pointer to the correct text file, which already now exists, and there's an empty problem statement, so we should be good to go there. Yeah. So don't really know what else to tell you other than that. It's been it's fun. It's gonna keep being fun. I'm just gonna have a little sip of this charcoal lemonade before I get started. Pretty decent. Charcoal lemonade's like it's a little as compared with some other things, but no big complaints. I took the day off from work today and went and played golf. Had one of my best rounds ever, which I can show you guys, but we've only got 6 seconds, so I won't bother you with the details right now. 3, 2, 1. Oh, there we go. Day 22, monkey map. Nope, that's the one we just did. Day 20. The monkeys take a surprisingly easy trail through the jungle. They're going in roughly the right direction according to your handheld device's grove positioning system, lol, GPS. As you walk, the monkeys explain the grove is protected by a force field. To pass through the force field, you either have to enter a password. Doing so involves tracing a specific path on a strangely shaped board. At least you're pretty sure that's what you have to do. The elephants aren't exactly fluent in monkey. The monkeys give you notes that they took when they last saw the password entered, your puzzle input. For example, this, 10R, 5L, 5R, 10L, 4R, 5L5. The first half of the monkey's notes is a map of the board. It is comprised of a set of open tiles on which you can move, draw a dot, and solid walls, tiles which you cannot enter, drawn hash. The second half is a description of the path you must follow. It consists of an alternating numbers and letters. A number indicates the number of tiles to move in the direction you are facing. If you run into a wall, you stop moving forward and continue with the next instruction. A letter indicates whether to turn 90 degrees clockwise or counterclockwise. Turning happens in place. It does not change your current tile. So for a path like 10R5, that means go forward 10 tiles, then turn clockwise 90 degrees, go forward 5 tiles. You begin the path in the leftmost open tile of the top row of tiles. Initially, you are facing to the right, so we're facing east from the perspective of how the map is drawn. If a movement instruction would take you off of the map, you wrap around the other side of the board. In other words, if your next tile is off the board, you should instead look in the direction opposite of your current facing as far as you can until you find the opposite edge of the board, then reappear there. For example, if you are at A and facing to the right, the place where you go is marked B. If you're at C and facing down, the tile in front of you is marked D. It is possible for the next tile after a wrapping around to be a wall. This still counts as there being a wall in front of you, and so movement stops before you actually wrap to the other side of the board. By drawing the last facing you had with an arrow on each tile you visit, the full path taken in the example above looks like this. Here, here, here around, down here, down there, and then you end there. To finish providing the password in this strange input device, you need to determine the number of your final row, column, and facing as your final position appears to the perspective in the original map. Rows start from 1 at the top and count downward. Columns start from 1 at the left and count rightward. The above example, row 1, column 1, refers to the empty space with no tile in it in the top left corner. Facing 0 for right, 1 for down, 2 for left, 3 for up. The final password is the sum of 1,000 times the row, 4 times the column, and the facing. In the above example, the final row is 6, the final column is 8, and the final facing is 0, so the final password is given this. Follow the path in your monkey's notes. What is the final password? Okay, so let's look at the input. Okay, cool. So let's see. String line equals scanner dot next line. If line dot equals break. And then we want string commands equals scanner dot next line. Cool. So now what we want is we basically want a grid. Let's look at our puzzle input, which is pretty big, but not like unfathomably big. Oh no, it's each one of these is 2 rows. Okay. Oh, gross. Okay, cool. All right, so this is mostly fine. We can basically just make a grid where like, this is really weird. What's going on with this? I'm not sure I like really understand. What's going on here? Let's take all of this and let's put it in here. Cool, so we can ignore how long this thing is and then just look here. Aha, so this is what's going on because the top row is like kind of empty. Got it. So it's this and then this and then this. Okay, I see it. And there's some stuff we could hard code if we wanted to. So this is character 151. So private static final int row width equals 151, right? Because it starts at 0, doesn't it? Here, go all the way back, 51. Maybe it's 150. 150 characters. Equals 150. Private static final int column size, and we're gonna change this to size. Equals, how many columns are there? Sorry, row size. How long is a row? Column size should be fine then, yeah. And columns are there are 200. 200. Private static final int test row size equals, what is it in the test row? So on our test board, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Is that right? Oh, but there's no spaces here? Yeah. 16. Private static final int test column size equals 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so what I want is I want a Boolean grid equals new Boolean, and that's what I want is private static final Boolean use test data equals true. If use test data, and I want int rows columns else rows equals row size and column size. Row size equals test row size. Column size equals test column size. We can just copy this and then we can just get rid of test. and that's we want. Oh gosh. So we want row size, which is the number of columns, and this will be row size, column size. Oh man, this is. We chose dumb names here. Rename this. Num columns. Rename this. Num rows. Rename this. Test num columns. Rename this. Test num rows. I know this seems like we're wasting time, but we're going to get better results here. Call this num columns. Call this num rows. Better, 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 better. Excellent. Cool. Otherwise, for int I equals 0, I is less than line dot length plus plus I. Int which row equals 0. And we want which row plus plus. Fantastic. I want grid. Which row I equals, and then I want line dot caret I is equal to, and let's put this on another line so this reads a little easier. It's equal to dot. And if that's true, then put true. Else put false. Fantastic. Oh, well, we don't have to, we can actually just, there we go. That's, if this is true, put true. Otherwise, put false. Is dumb. Okay, cool. So int, int start y equals 0, int start x equals 0, while grid start y, start x, well, not this, plus plus start x. And that's, let's rename those. Cur y, start 6, cur x. Cool. But we need to treat, crap. Okay. Okay, instead of a Boolean array, we're gonna have a capital Boolean array. If line dot caret I space, then grid which row I is null. Because yes, so if it's null, we can just skip over it. Probably fine. Cool. Excellent. Else this. Fantastic. So now we've got our commands. So now we want to, let's just call a function traverse. Let's make a little private static class position int x, int y, int direction. Let's leave us a couple comments here. 0 is right, 1 is down, 2 is left, 3 is up. Cool. So position equals new position. Position dot x equals for x. Position dot y equals for y. And position dot direction equals 0. Is that right? Yeah, it says 0 is right. This is v left. Make this all line up. And where is this? There it is. Wonderful. Okay, let's call traverse. Put this down at the bottom. Private, static. Do we want to make the positions traverse themselves? Yeah, the hard part might be trying to read this. String Java string split on 2 characters. Split a string by 2 delimiters. Yeah, because if we look at this, there's 10R and then there's 1L, then there's 2R. So we kind of like want to split it by R's and then split it by L's. Sure. Position, int x, int y, int direction. This dot x equals x. This dot y equals y. This dot direction equals direction. Void turn. Care. Which direction? If which direction equals L, then direction minus minus. Else if which direction dot equals R, direction plus plus. Else throw new runtime exception. Unknown direction plus which direction. Fantastic. If direction less than 0. Let's see. Direction equals direction %4. Direction less than 0. Direction plus equals 4. Fantastic. In fact, we can even solve this problem by just direction plus equals 4. And then do this. Because if we're at 4, then it'll go to 8, and then it'll go back. Direction, direction plus 4%, 4. There we go. Void, go forward, int how many. If direction is 0, yeah, let's call a void go forward 1. Let's make this private, and then we can just call this. For int I equals 0, I is less than how many, plus I. And this needs to take an int how many, and then a Boolean grid. This just needs to take in the grid. Go forward 1 grid. Fantastic. If direction equals 0, else, then we're just gonna copy this. One, 2, 3. Cool. If direction is 0, then we want to be trying to go. So if grid y x plus 1% grid 0 dot length, right? False. Return. Else, if int next x equals x plus 1, while what do I want actually? Grid y next x is null. Next x plus next x percent equals. Does that work? Yes. Grid y dot length. So that'll loop over. We should be fine. And then if it's return, otherwise x equals next x, right? So if grid, and we actually already did this part, so just whatever the next thing that's not null is, if it's false, which we can actually, rather than saying equals false, so if not that, return, else, actually we can just do this, x equals next x. We don't need the other thing. And then we're good. So now what is the equivalent of this for down? It's probably just next y equals y plus 1. Oh, it needs to be y plus 1. So we need to do this here. Part needs to be next y, next y, next y, next y. This should just be grid.length. This needs to go here, and this just needs to be x. Next y, x. Y equals next y. Cool. So that seems good. You can take this and copy it for this because this one's left. So this should be x minus 1. And then whatever next x plus equals, and then I want this just so we don't get negatives. Where's the equals? There we go. And then this should be minus minus, and then you got to do this. Yeah, and then we should be good. And for this one, we start by going one to the left, and then we got to do this same thing, except it's next y. It's just grid.length. Fantastic. Next y minus minus. Next y plus equals grid.length. For percent equals grid dot length, whatever. Cool. Cool. So reading a command is like numbers up until like an L or an R. So int and then on position we can go string, or what is it? Integer to final password, return x times 1000 plus y times 4 plus direction. Fantastic. So this will just be final password, which is plus position dot to final password. So then we want int command start equals 0. And int next command start equals 0. While what do I want? Commands dot caret next command start dot and what do I want? I want like characters dot is character dot is digit plus plus next command start. And then I want int num steps. So I want some stuff here, and then I want like while command start less than commands dot length. I want to do the same thing over and over again. Int num steps equals integer dot parse int commands dot substring command start next command start. Here direction equals commands dot caret next command start. Then I want position dot go forward. How many is num steps grid? And then do we always, or does it end with a turn? It does not end with a turn. Let's see. And this one also does not end with a turn. Okay, let's actually, I want to rewrite this a little bit. Start equals 0, while command start that. So I want if I want to rename commands. Command list line. Command list line dot caret command start. And I want like character dot is alphabetic. Else, and then do some stuff. Then I just want position dot turn this I'm going to change to command pointer, command index, and index plus plus. And this should not be command index. This should be in this line dot care at command index. Next command start. Don't care. Equals command index. Cool. And I don't care about the direction here. I just want to go forward, the num steps in grid, and then I want command index equals next command start. Great. So that should be good. Let's put in our test data. Let's see if all of that code that we wrote works. And use test data is true. So let's run it. We're inevitably going to get an exception, and then we'll figure it out. Required int, found no arguments. That is fair. We did screw that up. Cur x, cur y, 0. Now we don't have to touch the innards here. We could make them private, but we're not going to. Any other compiler errors? No. Num columns is the length of a row. Oh, this is stupid. Num columns. Okay. All right. Is that better? So we pick a row and then we go into that row. Okay. Is that better? Cannot invoke Boolean value because grid cur x, cur y is null. Where? Line 49. Wow. Grid cur x. Sorry, this should be cur y. Cur x not equal null. And equals null, or this. Oh, nope, don't want to debug, just want to run. Caret, whatever. Get to here. Command start, less than command list line dot length and. Okay, what about now? Well, we got the wrong final password, but we can at least figure out where we're going. So let's see what's going on here. So now let's debug, and I want to debug in here. Debug, please. Cool. So if we look at our grid, 0 is null up until 8, 9, 10, 11, 12, 13, 14, 15. Great, cool. And if we look at row 11, null, and then it's true, 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 false, true. Fantastic. It looks like we're doing fine. So we select a row and then we go to that row. And the row we selected is based on Y. That should be fine. So let's look at command list line. So it's not alphabetic, it's numeric. So now we want to get all of the stuff. And what do we get for num steps? 10, fantastic. So now let's dive into go forward. So we should be walking to the right. And we're just going to keep walking to the right. Basically just 3 steps. So here, let's go forward 1. Direction is 0. It's x plus 1. So 9. We're good. It's still 9. It's not null. That's true, so we should just set x equal to this. Then we should return. Then for this one, go here, go to 10. We're good. Step out. And we shouldn't be able to go to 11, right? Yeah. This should not let me go to 11. And then it should just keep not letting me go to 11. So if I look at position now, we should be at 0, 11. 0, 10, sorry. So we're right here. So we're good. So that part's okay. Cool. Bandit equals next thing. It is a character. Turn. Let's step in. Step into this one. So we're turning right. Is that correct? Yes, our first step turn is right. So now our direction should be down. Direction is still 1, so we're good. And 1 is down, right? 1 is down. We're good. And that's what happens when we turn right. So now we get the thing. And what is our number of steps is 5. So now we should go y equals 1, y equals 2, y equals 3, y equals 4, y equals 5. So we should just get to here. So we'll go here. Now what is position? 10, 5, direction is 1. So now we're going to turn left. Oh, I know what's going on here. Dang, we spent a lot of time there. X starts at 1. It should be plus 1 times 1 plus y plus 1 times 4. That's... Okay, let's keep debugging though. Go back up to where we are. So now we're going to try and go right. How many steps are we going to go? 5, which is correct. And that should take us over to here. So let's step in and see what goes on. Step forward 1, direction 0 is true. 11. Great. 11, 5. Don't have to worry about that. We're good. We just do this. We step up. Go in again. Then we go to 12, which if we look at grid Y, there is no 12. So 13, 14, 15. Next x is 0, return next x. So we're good. So if we step up, we should eventually be at 1, 2, 3. X is 3, y is 5, so we're fine. Okay, so what about now? Okay, so y is 7, x is 3, so we're cool. Now what's our thing? 7, 7? 0, 1, 2, 3, 4, 5, 6, 7. 7, 7. And then we're gonna turn and we're gonna go. And now we're 7, 5, which makes sense. Okay. Go X 7, 5. We're facing right. So the final row is 6. Oh, so the row, which is y plus 1. X plus 1. Okay, cool. So now if I run this, okay, so we just got this part wrong, but we totally stepped forward. 60, 32. Cool. So now if we do this, paste this here, and then we say use test data false. And then if we run, that runs super quickly. Nailed it. 6:16 on the stars leaderboard despite going really slow and methodical. I think we could have been done maybe 5 minutes ago. As we reach the force field, you think you hear some elves in the distance. Perhaps they've already arrived? You approach the strange input device, but it isn't quite what the monkeys drew in their notes. Instead, you are met with a large cube. On each of its 6 faces is a square of 50 by 50 tiles. To be fair, the monkey's map does have the 6 50 by 50 regions on it. If you were careful to fold the map, you should be able to shape it into a cube. In the above example, the 6 smaller 4 by 4 faces of the cube are 1, 2, 3, 4, 5, 6. you are still in the same position with the same facing as before, but the wrapping rules are different. Now, if you would walk off the board, instead proceed around the cube. From the perspective of the map, this can look a little strange. And you have example, if you're at A and move to the right, you would arrive at B facing down. If you're at C and move down, you'd arrive at D facing up. Okay, using the same method of drawing the last facing you had with an arrow on each tile you visit, the full path taken above now looks like this. The final password is still calculated from your final position and is facing the respective map. In this example, the final row is 5, the final column is 7, the final facing is 3, so the final password is this. Fold the map into a cube, then follow the path given the monkey's notes. What is the final password? Okay. So we're just going to copy all this from part 1, and we're going to change how position.getNext works. And we're going to do that by making, instead, we're going to make another class called position on cube. So like we're going to take this, and I got to do some weird stuff here. So let's take a look at this. So now when we like go from one of these, it's gonna, okay, so let's look at our input here and figure out, let's look here actually. Go over. Cool, so if we look at our numbers here, we should be able to figure out what this is. 200, 150, they're 50 by 50, cool. So this one's got, it's too wide. So I want to draw this on a whiteboard. Let me take my camera and futz with it a little bit. Is it control? It does not control. Is it alt? It is alt. Take this, and wow, there's so much over there. Cool. We're gonna do it like that, and then we're gonna come over here like this. We're gonna fix this, and then I'm gonna draw some stuff, and I'm just gonna talk a little louder, and hopefully this will carry over. So if we take this and if we zoom out a little bit so that this is easier to look at, and here we go. So we're basically like too wide up here. Here, yeah, the columns are so much bigger than the rows. So our sphere basically, or our cube basically looks like this. Right? Yeah, down to 50, we have the 2, and then we have the 1 right here, down to 100, and then we have 2 here, and then we got 1 at the bottom left. Cool. So first of all, the edges that are normal, let's label these. 1, 2, 3, 4, 5, 6. Yeah, note that the direction that we're facing is going to get a little weird. Oh man. Okay, cool. So let me write this then. So for 1 x y, this is 51 near 100. This is 101, or I guess it's actually 50 to 99. Is that right? 0 to 49. 50 to 99. Is y is 0 to 49, 2, 3, 4, 5, 6. Cool. And I think I'm actually probably going to have this as like six grids, and then we'll just make sure that we like map them up correctly. So 2 is 100 to 149, and still 0 to 49. 3 is 49. This is 50 to 99. This is 100 to 149. 100 to 149. And this is 150 to 199. Just in terms of like the thing that we're dealing with. Because again, our last row here is 200. That's weird. Oh, starting from line 1. Yeah, so if we index it the way that we would normally expect to. So this is still the middle one, which is 50 to 99. 4 is 50 to 99. This is 0 to 49. This is 0 to 49. Cool. So if we read in those 6 grids that way, which should be pretty easy to do, then what we're going to do is so basically on each square I want to know like which other squares that it matches up with. So if I think about this, like if one, here let's draw a cube, and then we're going to try and label the faces as we go. There's this face right here. Go there. So 1 is on the bottom and 2 is on the right. I guess here, let me think about it. 1 is on the top and 2 is on the right, and 3 is here. Then like 4 is, sorry, I didn't write this. 4 is like here. So this is the other way, I think. No, it is gonna look weird like that. It'll be like this. Yeah. This faces 2, 5. So 4 is here, then 5 is here. So this side is 5, and then 6 is here. Cool. The orientation is going to matter. So which ones are all connected up? One to the right comes in on 2 to the left. 1 down comes in on like 3 from the top. 1 left. See, we'll do it like it's 5 upside down. It's 5 is upside down relative to 1, so it's like 5's. So this connects here, this connects here. Six's side connects here. 2 and 3 connect here. 4 connects to 2 here. 4 and 6 obviously connect right here, and then 6 connects to 2 right here. Is that right? That looks right. Everything folds up, everything gets a little smaller, should be fine. Those 2 things fold. And this one folds into there. I wish I could just make a little piece of paper to try this out, but I think we're gonna assume that that's right. Not visible at all. Let me full screen and see whether or not you guys can see what I'm looking at there. Not entirely. Okay, I'm just gonna make this real big just for a second here for future edification. So you can see that I drew out the cube here and I figured out the faces and I drew the arrows. We're just gonna have to figure out, I'm gonna parse these into separate faces. And then I basically want to figure out how we're gonna have to transition from one face to another. Okay, so if we go back to additive code and we move our camera back to over here, now that you guys have seen what I will be referencing, we should be good to go. I don't know if I take a quick second and see who's in chat. You young rapscallions. Oh, nobody that I know, that's fine. Except for hydrated dev. Falling since 19 hours ago. You'll love to see it, hydrated dev. Hope you're having a good night. Okay, so let's zoom this back in now to a visible size so we can see what's going on. Yeah, there we go. Hopefully that's big enough. Cool. So let's start by reading in the faces. So instead of while scanner as next line, we're instead gonna parse stuff a little differently. And instead of grid, we're gonna do some other stuff. Yeah, maybe we do want to leave it as a grid, and then we're just gonna have like a helper method that does a bunch of stuff on the cube. Let's do that. So I want position on cube. New position on cube. Fantastic. And then we can still just do the right stuff. And so all that's gonna happen here is position on cube is gonna get different. On position and facing from the perspective of the map. Final row is 5, final column is 7. So the final password is blah 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 blah. Okay, cool. So go forward 1. So if direction is 0, and the direction is gonna get weird. So if grid Y next X null or anytime we're like wrapping around the edge, things are a little different. So actually I don't want to do this. Next X is greater than grid Y dot length. Yeah, so anytime we're like going through the map is normal. If we don't hit a region that's not null, then we don't have to do anything weird. So we're cool. Let me write a little helper method here below this one. Private int which face int x int y if x is greater than 49 and x is less than 99. So let's see, if x is so if x is less than 50, means we're in the first one. Then if y is less than 149, return y is less than 149, then return 5. Else return 6. Else if x is less than 100. If y is less than 50, return 1. Else if y is less than 100, return 3. Else return 4. Else if y else just return 2, right? Return 2. Cool. Oh, this is such a weird one. Also, we have a lot of people in chat. Hello, everyone. I hope you're doing well. I'm having a real hard time here. I'm trying to code a cube. I keep looking back because on my whiteboard I drew the cube that I'm trying to mess with. Basically, they gave us a map and we like fold it onto the surface of a cube and then get the right answers. Let's look at the stats real quick. See how many people have done this. Only 22 people have done part 2. That's kind of encouraging. Okay, back to it. Nope, that's the wrong one. I would have preferred that it was that one. Okay, cool. So we can tell which face we're on. Okay. Cool. And then each like area that we'd like end up in like maps to like the next face that we're trying to get to, right? I think so. I'm pretty sure that so let me move this back over here so you guys can see what's going on. And I'm going to full screen just for a second here. So, hey, everyone. Nice. I'm trying to fold a bunch of stuff onto the surface of the cube, and it's really hard, so I keep whiteboarding, which is hard to put in the video, but that's okay. We're figuring it out. Thanks. Yeah, I have to do this, and so whenever something walks off one side, I have to make it like hop to the other place, which is like really tedious to get right. You can see how this, if you like cut it out and fold it out into a cube. Yeah. So then like the idea is if the thing's walking around the cube, what's going on? So like, it's hard. That's complicated.
Good night.
Good night. Oh, what was it she wanted? Oh, we can pack tonight or tomorrow morning. Okay, great. Both for chemo, but also for the next day. So you don't want to do that. Okay, great. Cool. So if we're in, for example, we're like between 2 and 3. That means that we're like our x value is 2's x value, but our y's value is 3's. Yeah, gross. Okay, cool. So basically, based on the face that I'm on, like I can figure out which side I'm walking off of. Okay, so go forward 1, direction is 0. Okay, all right, cool, okay. Yeah. Yeah, weird. Weird. Basically, like the way this is going, we go here, then here, then here, which I think maps to here, and then here, which I think comes up here, and then here to there. Gross. Cool. Great. So, basically I want a method like so go forward 1. Okay, let's. So if grid y next x. Let's just call it walk off face. Which face x, y, which we actually don't even know. X and y are still there. Next x, y. Grid. Cool. We can figure out what walk-off fates needs to do, and for all the normal stuff we can leave this here. So we basically want to do the same thing here because this is right. So this is next y, and this is just x, and this is next y is greater than grid dot length. Then we want next y x grid. And then we can take this same thing, but it's going to go. So now we want if. Oh no! And for these, I gotta swap the order of them. That's one of those precludes a runtime error, and the other one doesn't. Here, there. Oh yeah, so much better. So now this, blah, 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 blah. So grid, this or that. Next x, and this can just be less than 0. Or if that's null, then we want to do that. And otherwise, we do this, we do that. We actually don't need this null part anymore in all these sections. And I'm praying that yeah, good. We're in position on cube. Excellent. Great. So And then this last one, its next y is less than 0, or the thing is null. Excellent. So now I want private void walkoff face int next x int next y grid, which is a Boolean grid. Fantastic. So now we got to figure out what's going on there. So if we're trying to walk off a face, we know x and we know y. So so let's switch which face x, y. What face are we currently on? Case 1, case 2, case 3. And then let's copy this. 4, 5, 6. Break. And let's put break on all of them. Break, 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 break. Cool. How do we figure out? So if we're in case 1, now we can use our bounds that we wrote down. So if we're on 1 and x is less than, okay. So if x is greater than, crap. Okay, cool. So that's, luckily things that are already on the grid are fine. So we actually don't have to do if x is greater than whatever. Like then we're cool. And if y is greater than whatever, we're cool because 2 and 3 are already connected there. Oh crap! I've been coding it. It's just by my face. Terrible. Okay, well that's fine. I hope you guys live with just this glorious Roman nose profile. Definitely not self-conscious about it. I'm not that self-conscious about it, but I recognize that it's a big nose, which nobody's ever insulted me about, but some women have liked. How we doing, Awfulsome? So if y is less than 0, if next y is less than 0, y is less than 0, then we'll deal with that case. Else, if, what's the problem? Next x is less than 50. So this, and we're just gonna have to code them all. Moving towards, next y is less than 0, then this connects to face 6. So let me go here a little bit more full screen again, and then we'll come back. So for one, this x now corresponds to this y. So x 50 to 99 corresponds to y, and it is higher. So 6 goes up to 199 corresponds to 150, 199. So this should be next y, and y is less than 0. Y is minus 1, so next x equals 0. Cool. So that's pretty easy. So it's phase 6. So now we want next y equals x plus 100, and we want next x equals 0. If we know there's not null, so if grid next y next x, if this is true, then we want to move there. X equals next x, y equals next y, and then direction equals, so if y is less than 0, we're going up, which is, and now up becomes right. So So direction is 0, and then return. Otherwise, actually, we don't even need to put the return here. The return just happens here. Okay, cool. So now let's do the same. Oh crap. Okay, I just gotta leave myself here, and we're just gonna accept the fact that the stuff on the board is gonna be a little bit small for you guys. So if next x is less than 50, so we're going to 5, and that part, this lines up with this, but in reverse. So x is less than 50, so then our y value, which is from 0 to 49, now becomes inverted. So next y goes from 149 to 100. Cool. So how do I do that? Oh, it's just 149 minus y. So next y equals 149 minus y. Next x equals, so next x is less than 50, and that actually is just going to become 0. If grid next y, next x, then this same set of things, but we got to figure out the correct direction. So if we're coming off here left, now our direction is right, so our direction is 0, so we're good there. Cool. So we're fine, and both of these should return. In fact, we can just call return here. Okay, so let's see case 2. Case 2 has 3 sides we need to care about. If next y less than 0, else if, yes, we are on part 2, Eric Wassel. I got like 600th on part 1, and now we're manually coding a bunch of this cube while I whiteboard it here in the background, which I know is probably relatively small, but every time I put it full screen, when I sit back down to code, I forget to click to put it back here, and you guys can't see the code. So kind of lose-lose. So if next y is less than 0, what's the other conditions? Else if next y is greater than 49? Yeah. Next y greater than 49. Else if actually, let's just call break here. No. We do want to call return. I'm just thinking like if things get weird and our conditionals aren't right or something. Else if next x greater than 149. Okay, so let's see. So if next y is less than 0, then that means we're moving into face 5. Moving into face 6. Moving into face 3. Moving into face 4. Wonderful. So let's see. Moving into face 6. Face 6. Okay, cool. So, that means our top now becomes the bottom. So next y equals 199, and the x here we're doing 2 and 6 connect. I figure out if there's any like flipping or anything that needs to happen, but I don't think so. I think we're good. I think like the direction that we're facing is okay. So we're fine, and all we need to do is next x equals x minus 100, right? Because in phase 2 we're 100 to 149, and here we're 0 to 49. Great. So next x equals x minus 100. Next y equals 199. All this is true, except our direction needs to be up, which is 3. Okay, so if we're moving into phase 3, then so our y now becomes so our x now is going to become our y, and our y is going to become our x. So xx equals the right edge of 3, which is 99. xy, the current x goes from 100 to 149, and then this goes from 50 to 99. So that's x minus 50. Is that right? Yeah. Okay. Next x equals 99. Next y equals x minus 50. And then if grid next y next x, and the direction is left, which is 2. Okay. So now for this one, we're going to phase 4. They're going to be upside down of each other. So next x is going to be equal to 99. Next y equals 149 minus y, right? Because the bottom of this is the top of that because it's flipped over twice. That seems right. Cool, let's give it a shot. Next x equals 99. Next y equals 149 minus y. If this, cool. So if grid next x, what's the direction here? So we're moving out of phase 2 and into phase 4, and we're going from right into now we'll be going left, which is also 2. Crazy. Next x is so I'm going into 4. And in phase 3 we're also going to the left. Yeah, it seems right. I need to drop double arrow here to not freak myself out. There we go. Oh, look at those double arrows, so much better. Okay. So now case 3. There's only 2 we have to care about. If next x is less than 50. Else if next this should return, not break. X is greater than 100 or greater than 99. Yeah, all of the other conditionals are, yeah, we're good. It's less than round numbers or greater than numbers ending in 9. So 3 on the left is moving into phase 5. We are moving into phase 2. So moving into phase 5, we can figure out. So next y equals 100, and next x equals, so it's lower in both. So we just need 3's y, which is 50 to 99 to match up with. So it's y minus 50. because higher in y is, or lower in y is lower in x. So that lines up. Need to do the same thing. So if this stuff, we could have just used the direction rather than doing these like weird conditionals. Oh well. So the new direction is down, which is 1. Else if next x is greater than 99, then next y is 49. Next x is, and we can look at what we just did, can't we? Moving into phase 3, x minus 50. So this is probably y, probably just y actually. This 3 is y, is 99 to 50. Y plus 50. If this, and the new direction is up, which is 3. Case 4, if next x is greater than 99, else if next y is greater than 149, moving into phase 2, moving into phase 6. Oh yeah, would you look at that? Beautiful. Okay. So if next x is greater, so we're moving into phase 2. Well, we already did this check, so we can like kind of do some of this stuff in reverse. Let's copy this. So moving into phase 2. So now it's like this kind of in reverse. So we know next x is going to be 149, that's for sure. And next y is 149 minus y. Does that work in both directions? Yeah, 149 minus 0 is 149, and 149 minus 149 is 0. So that is, it's actually the same in both. And our direction is going to be left, which is 2. No matter what, if we're going to the right, we end up coming out left. And if we're going to the right, then we end up coming out left. So we're good. Moving into phase 6 from 4. Next x is 49. Next y is x plus 100, is that right? Yeah, the right side, so x is 99, we want y to be 199. So just x plus 100. And then if we're going in this direction, what's our direction? So we're coming down, now we're coming left, which is 2, so we're cool. Great. Yeah, both the things that come out, and then for 3 and 5 we don't care. Not break, return. Case 5, if so 5, the ones we care about, so if next y is less than 100, else if next x is less than 0, that's probably, I don't have better stuff there, turn. If next y is less than 0, or next y is less than 100, then we're going to 3. Moving into phase 3, and here we're moving into phase 1. Gross, cool. Moving into phase 3, cool. So next x is 50. Next y is when x is 0, y is 50. Next y is x plus 50, is that right? X is 49, y is 99, that seems correct. We can copy this little boy. And then the new direction is to the right, which is 0. If we're moving on to face 1, then it's upside down of each other. So next x equals 50. Next y equals, and it should be what? 149 minus y? 149 becomes 0. 100 becomes 49. Minus y. Seem right? Seems right to me. 0 to 49, 50 to 99. Yeah. Let me copy this same boy. And the new direction that we're going is in fact to the right, so we're good. Okay, last one. If next x is less than 0, else if next x is greater than 50 or greater than 49, else if next y is greater than 199. And let's label the faces because we've been doing well. Moving into face 1, is that right? Face 1. Moving into face 4. Moving into face 2. All of which are going to be a little weird. If we're moving into face 1, then... oh no. X is left side, then 5, then 4, then 3, then 1. Yeah, so the top, and 1 is, the top of 1 is like this. So 0, 0. So the top and the left line up. So next x equals y minus something. X equals y minus, and we're at 149, and we need to be at 40, yeah. We're at 150, yeah. Y minus 100. Next y is 0. Fair enough. Our new direction is down. Else if next x is greater than 49, we're moving into face 4. Next x equals, I don't know yet, but next y is for sure 49, 99, 149. Next x is, okay, so larger y is larger x, so we're good. So it should be, and it's 149 to 200, it's 49 to, or 150 to 199, 50 to 99. So it should just be y minus 100 still. Okay, we can copy this. And the new direction is up, which is 3. And the last one. Next x equals, oh crap. Okay, so I think that just maps straight down. So next x equals x plus 100. Next y equals 0. Do the same thing, and then set our direction. What is our direction? Our direction is automatically going to be down, which is 1. And then we should be good. Okay, cool. So if I just go here and I just run part 2, then I just say, please run. What? Okay, so let's debug walk off face. Nothing? Oh, no, we need to get rid of this. Okay, so now what if we run? Run out of bounds for link 200. Yeah. Oh, this should be else if. Oops, okay. So that means similarly here, we need an else. Copy else. We either want to walk off the face or we want to deal with the whatever. Now run. Greater than or equal to grid.length. Less than 0, greater than or equal to grid wide.length. Here we go. Final password 3479. I'm almost certain this is incorrect, but let's give it a shot. Oh my goodness. You guys, we nailed that. We just, whoo. Oh, we got that stuff absolutely 100% correct. And we got rank 176 on this STARS leaderboard. Yeah, it took people an hour and 14 minutes. It took us an hour 25. We were 10 minutes away from being there. Dang. It is amazing that one person solved this 13 or 14 minutes faster than everyone else. Thank you, AwfulSim. I am super excited. I don't know if you guys have seen the stats, but 236,000 people did day one. 2,200 people have already finished part one of today. So yeah, and about 15,000 people do the problem every day. So to be 100 and something or whatever, I'm actually pretty proud of. That's really exciting. I am amazed that worked. The reason that I didn't want to try it on the test data is that I hard coded all of these like 99s and 50s and stuff, and I would have had to turn those into smaller stuff. Yeah, thanks. Oh man, I'm so pleased. I can't. Yeah, 176. Ooh. Less than 10 minutes away from placing. We out here for it. Let's take a little sip here and then we'll get to cleaning up some code. Yeah, nobody else has done today's. And I'll look at the other one just so that I can see the nice list of stars. Okay, let's get to putting this in here. Gross. Level 22 problem statement. There it is. Day 22, monkey map. Rising, let's see, force field and path are the words that we want. At least pretty sure. Puzzle input, for example. This. The first half is a map of the board. That makes sense. Requires a set of open tiles. I should have like noticed that the map was drawn weird to be a cube, but I just didn't like worry about it that much, man. Solid walls, tiles drawn, a hash. Second half of the description of the path you must follow. It consists of alternating numbers and letters. A number indicates this, a letter indicates this. We enter, we go like that, and then we come back, do this. Number of tiles to move in the direction you're facing. A letter indicates whether to turn 90 degrees clockwise R or counterclockwise L. So a path like 10R5 means go forward 10 tiles, turn 90 degrees, go forward 5 tiles. Facing to the right. If a movement instruction would take you off the board map, you wrap around there. Let's go here. For example, if you're at A, facing to the right, the title in front of you is marked B. If you were at, dang it, I want to do this. If you're at C and facing down, the title in front of you is marked D. It is possible the next tile to be a wall. Man, I just cannot believe that I clutched that math so hard still. Whoever gets that stuff right on the first try. Not me. Except apparently this one time. To finish, you need to determine the final row, column, and facing. Control F1 now. Rows start from 1. Columns start from 1. Left and count rightwards. And you have example row 1, column 1, first tile, no column in that corner. Okay, facing is 0 for the right, which is this. 1 for down, which is this. 2 for left, which is this. Oh, we gotta get the 2. Let's find out if it's my best ranking. Give me 1 second. The final path, when we get done marking part 1, then we'll do it. Okay, final row is 6. Final column is 8. The final facing is 0. Final password is blah, 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 blah. It is 632. What is the final password? I've gotten under 200 twice. So if I go to leaderboard, personal stats, 176. So it's definitely my best for part 2. But I got 129 on part 1 on day 16. You'll notice that I do better on the ones that take a long time. So my best ranking on any individual part is 129, and my best ranking on a part 2 is 176. So this is unsurprising to me, though. I'm using Java. It's not like I can write this stuff very fast. If I were using Python or whatever, I could probably write this stuff faster. But you know, when I need to figure complicated stuff out, like I'm using a language that I really understand, and I do this for a living. So unsurprisingly, I do okay. Here, strange input device. Instead, you're met with a large cube. That makes sense. Just 6 faces. Map does have 6 50 regions. If you were to carefully fold the map, you should be able to show it in the cube. Smaller 4x4 faces are here. I'll put an enter here. You start in the same position with the same facing as before, but the wrapping rules are different. Now if you walk off the board, instead you proceed around the cube from the perspective of the map, blah, blah, blah. I'm still awestruck. I can't get over it. It feels so good. Normally I feel so dumb. I guess like my real thing is that my standards are pretty high. So like I am usually, I mean, you know, I'm okay with wherever I finish. But normally I'm like, well, I should go faster, but I'm not really worried about it. But for this one, I don't think I should have gone faster. I think that this is among the best results I could have possibly expected. Final column is 7. Final facing is 3. So the password is, yeah, it doesn't even work for the test data. The map in a cube. Then follow the path given in Lucky's notes. What is the final password? Your answer was 3489. Both parts of the puzzle are complete. Okay. So let me look and see if there's anything about this code that I want to annotate, but like not really. Okay, here, let's annotate a little bit. Read in the grid. Read in the grid using null to demarcate cells to be ignored. Find the starting position in the first row. Command is a turn. Else. Command is, oh, and this needs to go inside. Command is a number of steps to take. Cool. Read in the grid using null to demarcate blank spaces. Find the starting position. Use new class to do cube wrapping. Command is a turn. Command is a number of steps to take. Cool. All right, cool. So let me explain how this works. So for part one, we read it in, and we just put everything in a grid, and we hard code the number of things that there are. We could figure that out dynamically or use a list of lists or something. I don't want to do any of that. The .get is gross. So we figure out the grid, and then we find our starting position, which is you just go along the top row until you find a value that's not null. So if the thing in the grid was a space, we mark it as null. If it's this, we mark it as true. If it's this, we mark it as false. So then what we do is we read through the command string, which is this really long list of numbers in R's and L's. And if it's an R or an L, then we just say, hey, position, please turn yourself. And turning is just, it's 0, 1, 2, 3. So if we're turning to the right, you just add 1 and then mod 4. Otherwise, we turn to the left, we subtract 1, then we add 4, then we mod 4. And that subtract 1, add 4, mod 4 makes it so the value is never negative, so we always get a value from 0 to 3. In theory, we could use something like an int def, but the numbers work out fine. If it's a number of steps to take, we just call on the position itself and say go forward and given a number of steps in the grid, and then it just calls go forward 1. And this was actually a really good abstraction of built in. So go forward 1 here just says, hey, if our direction is go to the right, try and go to the right, and then like wrap yourself around if you've gone off the right side of the grid. And then if the values are null, like keep going, and then only move yourself if when you finally get to something that's not null, if that new value is true, then go to that new space. Otherwise, stay where you are because there's a wall, even though there's a wall where you're wrapping around. We use similar logic for down, for left, for right. All of this is relatively trivial, and then we run it. That wasn't so bad. Part 2 gets more interesting. All of the parsing in is exactly the same. All of the finding the starting position is the same, but we use this new class position on cube. Turning is still the same, but go forward is different. So when we go forward here, we go forward 1, and if we end up off the bounds of the grid, or we end up in a place that would have been null, now we need to wrap according to the cube, which we drew on our whiteboard over here, and hopefully you can see. Let me full screen that for a second. So if I full screen this, let's put this over here, and we're gonna explain on the cube for a minute what's going on. So, on the cube, first of all, you'll notice in the contiguous pieces, 1, 2, 3, 4, 5, 6, I figured out which faces are where by using X and Y ranges, which you can just hard code because you know all this stuff there. If you're going, for example, from face 1 to face 2, they're already adjacent on the map, and the direction map's the same, so you don't do anything. So you only care if you step off the right side of the grid, you step off the left side of the grid, the top of the grid, the bottom of the grid, or if you go into the big vast array of nulls that exist in all of these places, which is where the spaces would be on the map typically. If you step into one of these areas, like here or here, or the spaces that should be here but aren't because of the way that they rendered the map. If you step into one of those spaces, I basically have drawn every empty edge goes to the next empty edge, and then this edge goes to that next empty edge, etc. And this is the folding of how the square is going to fold onto itself. And so then what I did is I figured out basically okay, so this y value ends up mapping to this x value on 6 and 4, and if we're going to the right here, we're going to end up going up there, etc. And I basically there's not that many pairs of edges. There's 1, 2, 3, 4, 5, 6, 7 different pairs to figure out. So I basically just said, okay, if you're going to walk off a face, go to the special function walk off face. And if you're on 1, then if you're going off the top, then you're going on the side of 6. And if you're going off the left, then you're going on the side of 5. And I just literally hard-coded how to figure out where the next thing is. And then I said, okay, well, if that value is false, don't go there, in case you end up with something like this, where you walk off this side, you should end up over here maybe, and then you would hit a wall so you don't move. So all that's great. We just straight up hard-coded it because there's only 6 sides. And so there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, because there's 7 pairs. And so, you have to do the same thing, but like in reverse in a few different places. And then the hard coding turned out to be correct with like no issues whatsoever, which is kind of incredible. Again, I'm still flabbergasted. Now you might think, oh, hard coding's like kind of gross. Don't you want something that's more abstract? And the answer is like, yeah, you could get a little bit more abstract with like how exactly you do this stuff, but trying to find something that takes like an arbitrary cube input and does this mapping like requires you to have some like logic of how you consider the folding, and that's smarter than I don't need this to work for like any input map. I just need this to work for the one input map, because again, like for this test example, this is a different shape than my actual like test data, which is in a different like more vertical shape than that one. So given that that's the case, I didn't really want to be bothered to figure that stuff out, so I didn't. And you'd say, okay, well, like so that's, by the way, the hard coding is all you need to do, and then you get the final password, which is computed as suggested, just the same as the other one. And so basically the only trick there is doing the wrapping correctly. And so you might also say like, okay, but like isn't hard coding it like slower than just writing the general case? And to that I would say, I don't know, man, look at that. I finished 176th out of all people, and I was 10 minutes out of placing the top 100, so probably fast enough. Hard coding was probably okay in this case. Awfulsome is pointing out in the Twitch chat. YouTube, you won't be able to see this because it's not on screen, but Awfulsome is pointing out that it doesn't work for a dodecahedron, and that is both absolutely correct, and also I do not care. I'm done with the problem. I am going to go have fun for the rest of the evening, whatever that looks like for me, which is mostly editing and uploading the video for this, and then probably playing some chess games for a while. But I appreciate everybody in Twitch chats that's been hanging out with me, especially you, Awfulsome. Always nice to have somebody talking in chat. Makes it a little bit more interesting for me. I'm going to go ahead and commit this stuff. Day 22 solution. Commit and push. Commit anyway and push. Push. Wonderful. You guys can, as always, find all of this code over on GitHub. And yeah, I think that's all I've got. I'm sad that there are only going to be 3 more days of this. All right, have a good night, everybody. See you in the next one.